Welcome, and close your eyes, take a slow, deep breath, and imagine yourself drifting gently among the stars. In this video, we'll journey through space, from the most basic ideas to the mysteries that still baffle the greatest minds, all in the calmest, most soothing way possible. So, get cozy, and let your mind wander as we explore the universe, from level 1 to level 100. So, let your thoughts float now. Level 1, space. Close your eyes and imagine you're drifting, gently, slowly, upward beyond all you know. You pass the trees, then the clouds, and keep rising until the sky turns from blue to black. You've left the world behind. You're now in space. But space is not a place with streets or sounds. It's not even a thing. It is the absence of place, a vast, endless stretch of nothingness. There's no air to breathe, no wind to feel, no up, no down. Only an infinite silence wrapped around you like a soft, dark blanket. Light travels here, but it takes its time, sometimes years, sometimes billions, and everything that has ever existed is sprinkled across this cold, silent ocean like glitter on black velvet. Stars, planets, dust, and dreams, all floating. You are now part of this grand stillness, floating among ancient starlight, surrounded by silence. You feel small, but not alone. Space is empty, yes, but not lonely. It holds everything, even you. So, breathe slow. Let your mind wander like a feather on the windless dark. This is where it all began, and this is where you are, resting in the arms of the universe itself. Level 2, no air, no sound. In space, there is no air, and where there is no air, there is no sound. That might seem strange. On Earth, we're surrounded by noise, birds chirping, cars passing, people talking. But out here, silence reigns. If you screamed in space, nothing would hear you. Not because space is cruel, but because it simply has no voice. Sound needs air to move through, like ripples through water. Without air, there are no ripples, no whispers, just silence. The purest, deepest silence you'll never hear. And yet, it's not empty. If you were floating here, you might still hear something. The soft thud of your own heartbeat, the sound of your breath inside your helmet, the quiet tick of your thoughts. This silence is calming, not scary. It wraps around you gently. Imagine being rocked in a cradle made of stars, where no alarms ring and no voices shout. Just peace, just calm. Here, you are weightless, motionless, soundless. You begin to realize that silence is not the absence of life. It is the beginning of peace. Let that quiet carry you. Let it soothe your mind. You are safe here, floating in the hush of the cosmos, where nothing interrupts your rest. Level 3, our home. Floating Earth, our beautiful home, is not sitting still. It's moving, fast. Right now, as you breathe and blink, Earth is flying around the sun at 67,000 miles per hour. That's nearly 30 times faster than a speeding bullet. And yet we feel nothing. No rumble, no tilt, just the gentle pull of gravity keeping our feet on the ground. But Earth doesn't just orbit the sun. It also spins like a top, one full turn every 24 hours. This spin gives us day and night, sunrise and sunset. And as we go about our lives, we forget we are on a ship, sailing through the vastness of space. From far away, Earth looks like a glowing marble. Blue oceans, white clouds, green forests. No borders, no noise, just beauty. It's the only place we know with life. Water flows, air breathes, life thrives, and all of it is floating. So tonight, As you lay down to rest, remember, you are moving, not just through time, but through space. You are riding a planet through the stars. Let that thought comfort you. You're part of something big, and yet held so gently. Earth carries you softly through the quiet dark. Level 4, the moon, Earth's companion. Look up and you'll see her. The moon, pale, round, glowing. She's been there longer than any city, older than any mountain, always watching, always circling. A silent companion in the sky. The moon pulls at our oceans, making tides rise and fall. Without her, Earth would wobble more. Our days would be different. She keeps us steady, calm. And even though she seems to glow, she has no light of her own. The moon is a mirror, gently reflecting sunlight back to us in the dark. Her surface is covered in craters, scars from long ago impacts. These marks tell stories of the past, of a time when the solar system was wild and young. Scientists believe the moon was born from a giant collision, a piece of Earth torn away and shaped into a companion. She always shows us the same face, turning just right as she orbits. Predictable, familiar, quiet. Some people say the moon helps them sleep. Maybe it's her stillness. Maybe it's the way she lights up the night without being too bright. As you rest, imagine the moon watching over you, not judging, just there, patient, peaceful. A glowing reminder that even in the dark, you are never truly alone. Level 5, the sun, our star of life. Now slowly turn your thoughts to the sun, not the burning brightness that makes you squint, but the quiet idea of it, the warmth you feel on your skin when you sit by a window, the gentle light that colors the sky in morning and evening. The sun is more than just a light in the sky. It's a star, our star. At its heart, the sun is a fiery furnace where hydrogen atoms are constantly fusing to become helium. This reaction releases energy, an unimaginable amount that travels millions of miles to reach us. And yet, when it arrives, it feels soft. It powers our weather, helps plants grow, and warms the oceans. The sun is ancient, over 4.5 billion years old, and will shine for billions more. Every second, it pours out light and heat, asking nothing in return. To us, it gives life. It keeps the Earth in orbit, holds the planets in line, and lights up the sky. Imagine that warmth now, not hot or burning, but steady and comforting, like a soft hand resting on your shoulder. Let that light soothe you. As you close your eyes, feel the quiet hum of sunlight, still traveling, still shining, still reaching you. You are never far from its touch. Level 6. Gravity holds it all. Gravity is the invisible hand that holds the universe together. It keeps your feet on the ground and the planets circling the sun. Without it, Earth would drift into the dark, and the moon would no longer follow us through the sky. It's not something we can see or hear, but its touch is everywhere. Gravity shaped the stars, the galaxies, and even time itself. It gently sculpts the paths of comets, curves the motion of planets, and draws dust together to one day become suns. It is why the oceans rise and fall, why tides whisper under moonlight. It pulls you toward Earth's center, while holding Earth in orbit around the sun. In the vast silence of space, gravity is a quiet but unbreakable bond, linking every piece of matter in a dance of motion and stillness. Even light bends around its grasp. So as you drift in thought, know that this gentle force holds you, Earth and the stars, together in perfect balance. Let your body sink a little deeper now, cradled by gravity itself. The universe is still, and you are safe within its quiet pull. Level 7. The observable universe. The universe stretches beyond imagination, yet we can only see a part of it. What we can observe, the observable universe, is shaped by the distance light has traveled since the beginning of time. Light moves fast, but the cosmos is unimaginably vast, so we live inside a bubble of visibility about 93 billion light-years wide. That means the light from the farthest galaxies took over 13 billion years to reach us. Beyond that edge, it remains hidden, for now. The observable universe is like a breath slowly expanding. Stars, planets, and galaxies are born, move, and vanish within its glow. And every night when you look up, you peer through this glowing bubble into the deep past. The stars are messengers. Their light tells us stories that began long before humans walked the earth. Each glimmer is a whisper across time. Inside this enormous sphere, Earth is a tiny speck, but it's ours. Let that thought comfort you. Though the universe is vast, you belong within it. So close your eyes and let your thoughts expand. Stretching. Level 8. Light and time. Light is more than brightness. It's a time traveler. When you gaze at the stars, you're not seeing them as they are, but as they were. Light takes time to travel. The nearest star beyond our sun is over 4 years away, which means its glow began its journey while you were still living a different day. The farthest galaxies we can see sent their light more than 13 billion years ago, before Earth had oceans, before life had begun. Light carries memories. It shows us the past. A cosmic postcard sent across the dark. That means space is like a mirror of history. When we look up, we're always looking back. It's a gentle, strange thing. The more we observe, the deeper into time we see. And we wonder, what does that star look like now? Is it still burning? Has it faded? In the dark quiet of space, time flows with light. It links us to distant suns and ancient worlds. So let your mind float backward now, carried on a beam of starlight, soft and slow. Level 9. What is a star? A star is not just a speck in the sky. It is a furnace of creation. Stars are born in great clouds of gas and dust, places so cold and dark that silence itself seems to live there. Gravity pulls the gas together until, deep in its center, heat and pressure ignite a fire that burns for billions of years. Inside that fire, atoms fuse. Simple things become complex. Hydrogen becomes helium, then carbon, oxygen, iron, everything we need to live. Stars are the universe's factories, and when they grow old, some collapse and explode, scattering those elements across space. That scattered stardust drifts, settles, and forms new things: planets, moons, and us. The iron in your blood, the calcium in your bones, the oxygen you breathe, it all came from stars. So when you look up and see that tiny light twinkling, know that it's more than just light. It's part of a long story, a star's story, and part of your story too. Let that thought warm you now, like a soft fire in the sky. A star is always burning, always giving, and you are part of that glow. Level 10. You are made of space. Take a breath. That air, it holds atoms that have drifted through the universe for billions of years. You are not separate from space. You are made of it. The carbon in your cells, the iron in your blood, the calcium in your bones, all forged in stars that lived, died, and scattered their gifts across the cosmos. Every part of you is older than the Earth, older than the Sun. You are not just in space, you are space, given shape and breath. The universe is not out there, distant and untouchable. It is inside you. It flows through you, moves with you. You are stardust, walking, a part of the great cosmic rhythm. You belong to the stars, the earth, the sky. You are held by gravity, lit by starlight, and cradled in time. And tonight, as you close your eyes, let that truth wrap around you like a warm blanket. You are not small. You are not lost. You are part of something vast, beautiful, and eternal. Let the universe hum softly around you, and let sleep come gently, as if returning home. Level 11, Mercury, the scorched stone. Close your eyes and imagine a world where the sun shines relentlessly for weeks on end, never setting. Then imagine the opposite, long nights of deep darkness that stretch just as long. This is Mercury, the smallest planet in our solar system and the one closest to the sun. It has no atmosphere to shield it, so during the day, temperatures soar to a blistering 800 degrees Fahrenheit. But when night falls, it freezes to hundreds of degrees below zero. This planet lives in extremes, shifting from scorching heat to freezing cold. Its surface is covered with countless craters, silent reminders of ancient cosmic impacts. Mercury has no moons to keep it company, no rings to decorate its skies, just vast emptiness. Yet, despite all this harshness, it quietly orbits the sun, enduring through billions of years, ancient and steady. It's a hot stone whispering secrets to the sun, a reminder of the wild variety of worlds in our vast cosmic neighborhood. Let your mind drift with this silent, glowing world as it races endlessly through space. Level 12, Venus, Earth's twisted twin. Now drift softly toward Venus, a planet almost the same size as Earth, but wildly different in character. Thick yellow clouds cover its surface, made of harsh sulfuric acid. These clouds swirl constantly, creating fierce storms, with winds that scream faster than any hurricane on Earth. Even though Venus lies farther from the sun than Mercury, its surface is hotter, hot enough to melt lead. The planet feels like a fiery furnace wrapped in a toxic veil. Long ago, people imagined Venus might have gentle oceans and life like Earth, but those dreams faded. Venus is not Earth's sister. She is her ghost, a planet trapped in a runaway greenhouse, baking under a thick, choking atmosphere. Picture this harsh, glowing world where heat and pressure reign, yet still it orbits silently, a harsh reminder of what might happen when a planet's balance is lost. Let this image fade gently, like a sunset into the calm night. Level 13, Earth, the Oasis. Now, come back home to Earth, the only place we know that cradles life. Oceans cover much of its surface, vast and deep, full of mystery and movement. Our atmosphere surrounds us like a soft blanket, protecting us from harm and keeping the perfect temperature for life. Earth is at just the right distance from the sun, not too hot, not too cold. This balance creates a fragile, beautiful oasis in the endless dark of space. From far away, there are no borders, no lines, only a beautiful swirl of blue seas, green forests, white clouds, and golden deserts. Earth breathes slowly as it spins, day and night weaving the rhythm of life. It holds all living things, including you, in a gentle embrace. As you lie still, imagine floating just above the planet's surface, cradled in the arms of this vibrant, living world. Let the soft rhythm of Earth's spin soothe you deeper into rest. Level 14. The Moon, Earth's companion. Look up gently, and there she is. The Moon, always watching, calm and steady. She pulls the oceans toward her, creating tides that rise and fall like a slow heartbeat. The Moon brightens the night sky, a pale glow against the dark canvas above. One side of the Moon always faces Earth, showing us a quiet, cratered face, a face marked by time and history. Long ago, a massive collision tore a piece from Earth, sending it into orbit where it became the Moon we know. She dances quietly around our planet, a constant companion. Some say the Moon helps us sleep, her calm presence easing the mind and heart. Maybe, as you drift off, she is watching you now, lighting the darkness with gentle, silver light. Let her soft glow wrap around you like a cozy blanket as you float toward peaceful dreams. Level 15, Mars, the red desert. Now, glide over to Mars, the red desert of our solar system. Rust-colored and cold, Mars is dry now, but long ago water flowed across its surface, carving valleys and riverbeds. Today, much of Mars is frozen, a silent, frozen world beneath a thin atmosphere. Its landscape is wild and extreme, towering volcanoes taller than Mount Everest, and vast canyons wider than anything on Earth. Mars has two tiny moons, Phobos and Deimos, small and potato-shaped, quietly circling far above its surface. Scientists wonder if Mars once supported life, if tiny creatures or plants might have thrived there in the distant past. Perhaps someday, Mars will come alive again, welcoming explorers and dreamers. Imagine floating slowly above this dusty, quiet world, feeling its ancient mystery and potential. Let the red dust settle softly in your mind as you drift towards sleep, dreaming of new horizons. Level 16, Jupiter, the mighty gas giant. Now, drift deeper into the vastness of space and arrive at Jupiter, the king of planets. It's the largest and most massive in our solar system. So massive, in fact, that it outweighs all the other planets combined. Jupiter is a swirling, roiling sphere made mostly of hydrogen and helium gas, with no solid surface to stand on. Instead, you'd find layers of clouds spinning wildly, creating incredible storms that rage for centuries. The most famous of these is the Great Red Spot, a gigantic storm so huge it could swallow the Earth 3 times over. Jupiter hums with raw power, its enormous magnetic field stretching millions of miles into space. Surrounding this giant world is a family of moons, dozens of them, each unique and fascinating, like tiny planets circling a massive star. These moons create a miniature solar system of their own, full of mysteries and hidden secrets. Imagine floating in the swirling clouds of Jupiter, feeling the immense energy pulsing through the giant world as it quietly reigns in the cosmic ballet. Level 17, Saturn, the Lord of the Rings. Now, slowly turn your gaze to Saturn, the elegant golden planet wrapped in magnificent rings. Saturn is a dazzling jewel in the night sky, its shimmering rings made not of solid rock, but countless particles of ice, dust, and fragments from shattered moons. These rings glow softly, creating one of the most beautiful sights in the solar system. Like Jupiter, Saturn's surface is hidden beneath thick clouds, swirling with storms and mystery. But Saturn is more than its rings. It's a planet of wonder and poetry. Its largest moon, Titan, is wrapped in a thick orange atmosphere, where strange weather and lakes of liquid methane hint at an alien world. Saturn invites us to dream, to wonder about the secrets beneath its clouds and in its icy rings. Let your mind float gently alongside this golden giant, feeling the quiet magic of its rings turning slowly, gracefully, in the vast darkness. Level 18. Uranus, the sideways world. Next, we float toward Uranus, a pale blue planet with a cool, distant presence. Unlike any other planet, Uranus spins almost on its side, as if it had been knocked over in a cosmic collision long ago. This unusual tilt means its poles point almost directly at the Sun during parts of its orbit, creating strange and long seasons. The atmosphere is cold and calm, colored soft shades of blue from methane gas high above. But beneath the surface, strange things stir, maybe deep oceans of ammonia and water, or perhaps something more mysterious and unknown. Powerful winds roar across Uranus's icy clouds, howling far above where we can see. It's a quiet planet, distant and enigmatic, holding secrets in its cold, blue depths. Picture yourself drifting over its tilted axis, feeling the alien calm of this sideways world as it slowly spins in its lonely journey around the Sun. Level 19. Neptune, the windy blue giant. Now, journey to Neptune, the farthest known planet in our solar system. Neptune shines with a rich, deep blue color, like a sapphire shining in the dark vastness of space. It is the coldest planet we know, yet paradoxically, its winds are the fastest, howling across its atmosphere at speeds over 1,000 miles per hour, faster than any hurricane on Earth. Neptune's largest moon, Triton, is unusual too, orbiting backward around the planet, caught in a frozen dance. Triton's surface is icy and mysterious, reflecting the deep cold of this distant world. Neptune itself is quiet but fierce, a giant of wind and ice. Its name comes from the Roman god of the sea, and it lives up to that legacy. Wild and untamed, hidden in the cold reaches of space. Imagine floating in the blue storms of Neptune, feeling the fierce winds and the quiet strength of this distant giant as it guards the edge of our solar system. Level 20. Pluto and the Kuiper belt, the icy edge. And now, drift gently to the far edge of our solar system, to Pluto. Once known as the 9th planet, Pluto is now called a dwarf planet, but it remains a world of wonder. It's small, icy, and distant, with a surface marked by a heart-shaped glacier, glowing softly in the deep cold. Pluto's companion, Charon, is almost the same size, and together, they spin around each other in a frozen waltz, locked in a delicate cosmic dance. Beyond Pluto lies the Kuiper belt, a vast region filled with billions of icy objects, tiny frozen worlds, rocks, and remnants from the solar system's birth. This dark, distant belt waits quietly in the shadows, holding secrets from the earliest days of our cosmic neighborhood. Imagine floating in the cold silence, surrounded by countless icy bodies, feeling the vastness of space stretching beyond. It's the edge of our known solar system, a place of mystery, quiet beauty, and endless dreams. Level 21. What is the Sun? As you gently drift through the vastness of the solar system, turn your gaze toward the blinding warmth of our Sun. From this distance, it looks peaceful and steady, a glowing ball of light hanging in the sky. But inside, the Sun is a fierce nuclear engine, constantly burning and transforming itself. At its core, hydrogen atoms squeeze together in a process called fusion, turning into helium and releasing enormous amounts of energy. This energy travels outward as light and heat, taking about 8 minutes to reach Earth, where it nourishes every living thing. The sunlight warms the oceans, stirring winds that shape weather and fuels the green growth of trees and plants. Without the sun's energy, Earth would be a frozen, lifeless rock drifting in the darkness of space. It's not just a bright light above us. It is the heart of our solar system, the source of all life here. Every breath you take, every moment you live, depends on this fiery star. The sun is more than a star. It is the reason you exist. Level 22. Solar flares and storms. Beneath the surface of the sun, a stormy chaos constantly brews. Powerful loops of magnetic energy twist and snap, erupting out into space in massive bursts called solar flares. These flares release waves of charged particles, shooting across the solar system at incredible speeds. Sometimes, these storms are so strong that when the particles reach Earth, they crash into our planet's magnetic shield, creating shimmering curtains of light called auroras, northern and southern lights, that dance across the night sky in vivid greens, reds, and purples. These light shows are breathtaking, yet they remind us of the sun's immense power and unpredictability. Solar storms can disrupt satellites' communication and even power grids here on Earth. The sun may seem calm and steady, but it is alive with energy and storms, reminding us that even stars have tempests of their own, raging in silence across space. Level 23. The life cycle of stars. Every star in the universe has a story, a beginning, a life, and an end. Stars are born in enormous clouds of gas and dust, drifting silently in space. Gravity slowly pulls these clouds together, condensing the material into tighter and tighter clumps. Over millions of years, the core of this gathering mass heats up until it reaches the intense pressure needed to ignite nuclear fusion. At that moment, a new star is born, shining brightly in the dark void. Stars will shine for millions or billions of years, depending on their size and fuel. But, like all things, stars cannot shine forever. Eventually, the fuel runs out, and the star begins to fade. Some stars quietly cool and disappear, while others explode in spectacular supernova, scattering their elements into space. This cycle of birth and death spreads the building blocks for new stars, planets, and even life itself across the cosmos. Level 24. How stars are born. Imagine a vast, dark cloud stretching far beyond our solar system, a cloud made of tiny dust particles and invisible gases floating in space for millions of years. Within this silent cloud, gravity begins its slow, relentless work, pulling the dust and gas inward, layer by layer. As the cloud shrinks, it grows denser and hotter in the center. Over time, this gathering mass becomes so compact and hot that a spark ignites in the core, the very beginning of a new star. This newborn star bursts into light, breaking the darkness with its glow, shining brightly for the first time. Around it, planets may one day form from leftover dust, orbiting the new star in delicate balance. The birth of a star is a slow, quiet miracle. A gentle awakening that lights up the dark spaces between worlds and begins the cycle of cosmic life anew. Level 25. Red dwarfs and yellow suns. Not all stars are alike. They come in many shapes and sizes. Some, called red dwarfs, are small and cool compared to our sun. These stars burn their fuel very slowly, shining faintly but steadily for trillions of years, far longer than our sun will last. Red dwarfs are like quiet embers glowing in the dark, patient and enduring. Our Sun, however, is a medium-sized star known as a yellow dwarf. It burns hotter and brighter than red dwarfs and has a lifespan of about 10 billion years. Yellow stars, like the Sun, provide steady warmth and light, creating stable environments where planets like Earth can support life. These gentle giants hold entire solar systems in their gravitational embrace, keeping planets in perfect orbits. Both red dwarfs and yellow suns are cosmic furnaces, their glow shaping the possibilities of life across the universe, each in its own unique way. Level 26. Giants and supergiants. Some stars grow to astonishing sizes, hundreds of times bigger than our Sun. These colossal stars are called giants and supergiants, and they live fast, dramatic lives. As a star nears the end of its life, it swells into a red giant, growing so huge that it could swallow nearby planets whole. Its surface cools, glowing with a deep red light, as it becomes a bloated, shimmering sphere in space. Even larger than giants are the supergiants, the true giants of the universe. These stars burn their fuel at a furious pace, shining with incredible brightness, but living very short lives in cosmic terms. Their end comes in spectacular explosions called supernovae, lighting up the sky like a brilliant firework and scattering star stuff across the galaxy. These stars might be short-lived, but their final moments create the very elements that build planets and people. Giants and supergiants remind us that the universe is filled with both beauty and power, light and change. Level 27. Binary and trinary stars. Not all stars journey alone through space. Some travel in pairs, locked together by gravity in a delicate dance. These are binary star systems, where two stars orbit around a shared center, spinning endlessly in cosmic harmony. Imagine the sight from a nearby planet, where two suns shine in the sky. Double sunsets, double dawns. Even more fascinating are trinary systems, where three stars circle each other, creating a triple star dance. Standing on a world in such a system would mean witnessing three sunsets, three dawns, and a sky filled with wonders, unlike anything on Earth. These multi-star systems are common in our galaxy and show us how diverse and surprising the universe can be. The interactions between stars in these systems can shape the fate of surrounding planets, sometimes making conditions for life more complicated or more extraordinary. Level 28. Variable stars. Some stars have a unique rhythm. They don't shine steadily, but pulse in brightness over time. These are called variable stars. Over hours, days, or even years, they grow brighter and then dim, like cosmic heartbeats. This pulsing happens because of changes inside the star, its size, temperature, or energy flow shifting in a steady pattern. Variable stars are incredibly important for astronomers. Their rhythmic brightening and dimming act like natural cosmic lighthouses, helping scientists measure distances across space with great precision. By studying the pulses of these stars, astronomers can map the size of the universe and understand more about how galaxies move and grow. These stars' light carries a hidden message, a cosmic language that speaks to anyone who listens carefully enough, telling stories of space, time, and the vast distances that separate us all. Level 29. Star clusters. Stars often come into the universe together, born from the same clouds of gas and dust. These star families form glowing clusters, groups of stars bound by gravity, shining side by side. Open clusters are young and loosely packed, like a scattered handful of sparkling jewels in space. They contain a few thousand stars, bright and vibrant, still close to their birthplace. On the other hand, globular clusters are ancient and enormous, containing hundreds of thousands of stars packed tightly into a spherical shape. These clusters orbit the centers of galaxies, including our own Milky Way, and are some of the oldest objects we can see in the universe. Within these clusters, stars share a history and a future, their light weaving together a story of creation and survival. Star clusters remind us that even in the vastness of space, stars are rarely alone. They are part of a family shining through time. Level 30. Dying stars. Every star, no matter how bright, must one day face its end. Small stars, like our sun, slowly burn out and shrink into white dwarfs, dense, cooling embers that glow faintly as they fade into the background of space. Larger stars meet a far more dramatic fate. When they exhaust their fuel, they explode in a brilliant supernova, a cosmic explosion so bright it can outshine entire galaxies for a short time. This final flash scatters the star's elements, carbon, oxygen, iron, across space, seeding the gas and dust clouds where new stars and planets will form. The death of a star is not a true end, but a transformation, a powerful cycle that creates and renews. From these deaths, new worlds are born, and the building blocks of life itself are spread across the cosmos. Stars show us that endings lead to new beginnings, and in the universe, everything is connected in a never-ending dance. Level 31. What is a moon? Not every world shines with its own light. Some are illuminated by the reflected glow of a nearby companion, a moon. Moons are natural satellites, orbiting planets quietly like loyal friends. They come in many forms, some rocky and cratered, others smooth and icy, some tiny, some as large as whole planets. Moons have a powerful role in shaping their planet's stories. Our own moon stabilizes Earth's tilt, calming its wobble and keeping our seasons steady. Without it, the tides would be weaker, and life as we know it might never have evolved. Moons pull on their planets with gravity, stirring oceans, guiding climates, and even protecting against dangerous space debris. Though small compared to the stars, moons are mighty in their influence. They whisper secrets of ancient collisions and cosmic dances, telling us about the birth and evolution of worlds. A moon may seem like a simple companion, but it holds the power to balance, protect, and shape entire planets. In this vast universe, moons remind us that sometimes the quietest partners have the biggest impact. Level 32. Io and Europa, Jupiter's moons. Now let's drift toward the giant Jupiter and its fascinating moons, Io and Europa. Io is a world alive with fire and fury. Its surface is a swirling canvas of volcanoes, the most active in our entire solar system. These fiery mountains erupt constantly, reshaping the landscape and painting it with bright sulfur colors. Io's restless energy comes from Jupiter's powerful gravity, pulling and squeezing it, creating internal heat that fuels the volcanoes. Nearby, Europa offers a different kind of mystery. Beneath its smooth, icy shell lies a hidden ocean, a vast saltwater sea that might hold more water than all of Earth's oceans combined. Scientists believe this warm ocean, kept liquid by heat from Europa's core, could harbor life, tiny organisms swimming in the dark beneath miles of ice. These moons reveal Jupiter's incredible power and the incredible variety of worlds that orbit just one planet, from fiery lava fields to frozen seas filled with hope. Level 33. Titan and Enceladus, Saturn's moons. Saturn's moons are no less strange and mysterious. Titan, the largest, wears a thick orange haze that hides its surface from view. Its atmosphere is dense, rich with nitrogen and methane, creating lakes and rivers, not of water, but liquid methane and ethane. This strange landscape ripples and flows like Earth's, but in a colder, alien way. Enceladus, though small, just about 300 miles across, is one of the most exciting moons in our solar system. It shoots icy geysers from cracks near its south pole, spraying water vapor and ice particles into space. Beneath Enceladus's frozen crust lies a hidden ocean, warmed by tidal forces from Saturn's gravity. This ocean could be a promising place to search for life, as it contains water, energy, and the building blocks needed for living organisms. Titan and Enceladus show us that moons can be worlds of mystery and possibility, holding secrets far beneath their surfaces. Level 34. The Asteroid Belt. Between the orbits of Mars and Jupiter drifts a vast broken world known as the Asteroid Belt. This region is filled with countless rocky fragments, leftover pieces from the early days of our solar system when planets were still forming. These objects range in size, from tiny pebbles to massive bodies, hundreds of miles wide. They drift slowly around the sun, spinning, colliding, and telling stories of ancient cosmic events. The asteroid belt is like a graveyard of failed planet-building attempts, a field of rocky rubble scattered across space. These asteroids hold clues about the conditions and materials present billions of years ago. Some are heavily cratered, others are smooth and irregular, and some even contain precious metals or ice. Despite their scattered nature, asteroids remind us of the solar system's turbulent youth and the powerful forces that shaped it. They're silent storytellers, whispering from the edge of the planets. Level 35. Famous asteroids: Ceres, Vesta, Psyche. Among the many asteroids, a few stand out as unique worlds of their own. Ceres, the largest in the asteroid belt, is round and icy, a dwarf planet with hidden reservoirs of water beneath its surface. It might even have the ingredients to support simple life. Vesta shines brightly, its surface covered in frozen lava flows, ancient scars from volcanic activity that tell tales of a violent past. Then there's Psyche, a metal-rich asteroid, almost entirely made of iron and nickel. Scientists believe Psyche is the exposed core of a protoplanet that lost its outer layers long ago. A rare glimpse into the heart of a world in formation. Visiting these asteroids is like traveling to ancient cities, ruins of a solar system still in the process of building itself. They hold secrets about the earliest moments of planetary creation and help us understand how the rocky planets, including Earth, came to be. These asteroids are more than space rocks. They're windows into our cosmic past. Level 36. What is a comet? Comets are some of the most mysterious and beautiful travelers of our solar system. Imagine a small, icy body that has been silently drifting in the deep cold for billions of years, far beyond the warmth of the sun. Made of frozen gases, dust, and rocky materials, these icy wanderers have been frozen in time since the very birth of the solar system. But when a comet's orbit brings it closer to the sun, something magical happens. The sun's heat causes the comet's ices to vaporize, creating a glowing atmosphere called a coma and a bright tail that stretches millions of miles behind it. This glowing tail is made of gas and dust pushed away by solar winds. shining brightly as it reflects sunlight. Some comets are regular visitors, returning every few decades like cosmic clocks. Others visit only once, blazing across our skies before disappearing back into the darkness of space forever. They hold clues to the earliest days of our solar system, carrying ancient materials that have remained unchanged for billions of years. Comets remind us that even in the vastness of space, the past is never far away. Level 37, Halley's Comet, the Time Traveler. Every 76 years, the skies welcome a very special visitor, Halley's Comet. Known for centuries and recorded by ancient civilizations, Halley's Comet is one of the most famous comets in history. Its bright tail and glowing coma have fascinated humanity for thousands of years. Chinese astronomers documented its appearance long ago, and it famously appeared in the year 1066, shining brightly during the Norman invasion of England, a sight many took as an omen. More recently, it passed Earth in 1986, allowing modern scientists to study it up close with spacecraft. The comet follows a predictable orbit around the Sun, returning to view every 76 years like a celestial clock. It will grace our skies again in 2061, connecting generations with a shared moment of wonder. Halley's Comet is more than just a comet. It is a time traveler, linking past and future, reminding us of the cycles of nature that continue long beyond a human lifetime. Its bright return in the sky is a reminder of the vast, beautiful dance of the solar system we are all a part of. Level 38, the Kuiper Belt, the frozen edge. Far beyond Neptune, the 8th planet from the Sun, lies a mysterious and icy frontier called the Kuiper Belt. This vast region is filled with countless small, frozen worlds made mostly of ice and rock, remnants from the early days of our solar system's formation. The Kuiper Belt is like a cosmic junkyard, where leftover pieces that never formed into full planets drift silently in the cold darkness. Dwarf planets such as Pluto live here, along with many other icy bodies, some only a few miles wide, others larger and round. The sun's light barely reaches this region, making it a deep freeze where temperatures drop to nearly absolute zero. It's a place of stillness and mystery, untouched by time. Scientists believe the Kuiper Belt holds clues about how our solar system was born and evolved. It is also the source of many short-period comets that visit the inner solar system, shining briefly before retreating again to the cold. This frozen edge reminds us how vast and varied our cosmic neighborhood truly is. Level 39, the Oort cloud, the solar halo. Beyond even the Kuiper Belt, far at the very edge of the sun's influence, lies the Oort cloud, an immense spherical shell of icy fragments surrounding the solar system like a ghostly halo. Unlike the Kuiper Belt, which is more like a ring, the Oort cloud extends in all directions, thousands of times farther from the Sun than Neptune. We have never seen it directly, but astronomers believe it exists based on the orbits of long-period comets that suddenly appear from deep space. These icy bodies slowly orbit the Sun in distant darkness, drifting quietly for millions or billions of years. Occasionally, a passing star or gravitational disturbance nudges an object from the Oort cloud, sending it hurtling inward toward the Sun. This triggers a spectacular journey, sometimes lasting millions of years, as it becomes a comet visible from Earth. The Oort cloud acts like a distant guardian, a boundary between our solar system and interstellar space. preserving ancient material from the solar system's formation. It is a mysterious frontier, marking the limit of our sun's reach and reminding us how small Earth is in the grand cosmic ocean. Level 40. Impact events. Visitors from space. Throughout Earth's history, our planet has been visited by many cosmic travelers, rocks, comets, and other space debris that crash through the atmosphere and strike its surface. These impact events remind us that the universe is not just a peaceful void, but a dynamic and sometimes violent place. One of the most famous impacts happened about 65 million years ago, when a massive asteroid about the size of a city slammed into Earth. The force of this collision was unimaginably powerful. It triggered fires, tsunamis, and a global climate shift. This event caused the extinction of the dinosaurs, wiping out nearly 3/4 of all species on Earth. It cleared the way for mammals to rise and eventually for humans to appear. Impacts like these have shaped Earth's history, changing the course of life itself. Though rare, such cosmic collisions serve as reminders that Earth is part of a larger, ever-changing solar system. The universe gives life, but sometimes also reshapes it, a powerful force that connects us to the stars. Level 41. What is a galaxy? Imagine standing beneath the vast night sky, where billions upon billions of stars shimmer and dance. But these stars are not scattered randomly. They form massive, beautiful structures called galaxies. A galaxy is like a giant city in space, made up of stars, gas, dust, and mysterious dark matter, all bound together by gravity's invisible threads. Each galaxy holds hundreds of billions of stars, many with their own planets and moons. Some galaxies are graceful spirals like the Milky Way, with arms swirling outward in majestic patterns. Others are elliptical, smooth and round, while some look chaotic and irregular, shaped by ancient cosmic collisions. There are more galaxies in the universe than grains of sand on every beach on Earth combined. Yet, each one is unique, with its own story of creation, growth, and change over billions of years. As you gaze upward on a clear night, you glimpse only a tiny part of one galaxy's light, reminding us how vast, mysterious, and beautiful our universe truly is. Level 42. The Milky Way, our home galaxy. Look up on a clear night and you might see a faint, glowing band stretching across the sky. That's the Milky Way, our home galaxy. It's a spiral galaxy, shaped like a giant pinwheel, with hundreds of billions of stars swirling around its center. Our solar system is tucked away in one of its spiral arms, like a quiet neighborhood in a huge cosmic city. The Milky Way is enormous, over 100,000 light-years wide, and it spins slowly, completing one full rotation every 230 million years. Since Earth was formed about 4.5 billion years ago, we've only completed about 20 orbits around its center. The stars, clouds of gas and dust in the Milky Way, create breathtaking sights, from bright star clusters to glowing nebulae. This galaxy is not just a collection of stars. It's the vast environment that nurtures our solar system, influences its motion, and connects us to the larger universe. Every night, the Milky Way's glow reminds us of our place in this immense cosmic community. Level 43. Types of galaxies. Spiral, elliptical, irregular. Galaxies come in many fascinating shapes and sizes, each telling a different cosmic story. The most famous type is the spiral galaxy, like our own Milky Way, where stars and gas swirl in graceful arms around a dense core. These spirals sparkle with young stars and glowing nebulae, places where new stars are born. Then there are elliptical galaxies. These are more rounded or stretched, smooth, and often older. They contain many old stars and less gas, so fewer new stars are formed. Finally, irregular galaxies look chaotic and misshapen, often the result of collisions or gravitational pulls from nearby galaxies. Each type reveals something about the history and future of the galaxy. Spirals show ongoing life and star formation. Ellipticals tell stories of aging star cities, and irregulars are signs of cosmic chaos and change. Studying these shapes helps astronomers understand how galaxies grow, interact, and evolve over billions of years. Level 44. Star formation in galaxies. Within every galaxy are stellar nurseries, vast clouds of gas and dust where new stars are born. These clouds, called nebulae, collapse under the force of gravity, growing denser and hotter over time. When conditions become right, nuclear fusion ignites, and a new star is born, shining bright against the cosmic darkness. These stellar nurseries are the heartbeats of galaxies, constantly renewing them with fresh stars. Around some young stars, disks of dust may swirl, gradually forming planets, moons, and perhaps even life. Star formation shapes the very structure of galaxies, lighting up arms and filling space with energy. The colors and brightness of galaxies are largely determined by these newborn stars and the clouds around them. Watching star formation helps astronomers understand how galaxies grow and change, and how the building blocks for life might spread through the universe. Level 45. Galactic collisions. Galaxies are not lonely islands. They move through space and sometimes collide with each other in slow, majestic dances. When two galaxies meet, their stars rarely crash because of the vast distances between them. But their clouds of gas and dust do collide, compressing and triggering intense bursts of star formation called starbursts. These cosmic encounters can distort galaxies' shapes, stretch out long tidal tails, and even merge two galaxies into one larger, more complex galaxy. Our own Milky Way is slowly approaching the Andromeda Galaxy, and in about 4 billion years, they will collide and merge, reshaping both. These grand collisions are violent but creative, transforming galaxies and seeding new generations of stars. Galactic collisions reveal how the universe is dynamic and ever-changing, with galaxies constantly evolving over billions of years. Level 46. Supermassive black holes. At the very heart of almost every galaxy, including our own Milky Way, sleeps an extraordinary cosmic giant, a supermassive black hole. These enigmatic objects contain millions, sometimes billions, of times the mass of our Sun, all crushed into a region smaller than our solar system. Their gravity is so intense that nothing, not even light, can escape once it crosses the black hole's event horizon, rendering them invisible to direct observation. Yet, their presence is betrayed by the violent dance of stars and gas caught in their grasp, swirling faster and faster as they spiral inward. When supermassive black holes feast on surrounding material, they ignite spectacular bursts of energy, shooting enormous jets of charged particles across vast distances in space. These energetic outflows influence the very shape and fate of their host galaxies, controlling star formation and regulating the galactic environment. Far from being silent devourers, these black holes act as powerful engines at the center of galaxies, shaping the evolution of the universe itself. Though invisible, their impact echoes through space and time, making them some of the most fascinating and mysterious objects we know. Level 47. The Local Group. Our Milky Way is not an isolated island in the vast cosmic ocean. It belongs to a close-knit family of galaxies called the Local Group, a collection of about 50 galaxies bound together by gravity. This group includes massive neighbors like the Andromeda Galaxy, our largest companion, visible from Earth as a faint smudge in dark skies, and countless smaller dwarf galaxies, tiny clusters of stars that drift quietly alongside their giant siblings. These galaxies move gently in a gravitational dance, orbiting one another and gradually drifting through the universe. The Local Group is our cosmic neighborhood, a small cluster of galaxies within the much larger universe. But it is incredibly important to us. It's a place where galaxies interact, sometimes exchanging stars or colliding, slowly shaping each other over billions of years. This cosmic family is also quietly expanding outward, stretching away from other groups of galaxies as the universe grows. Within this neighborhood, our sun's journey around the Milky Way unfolds, reminding us how small we are in the vastness of space, yet connected to a grand cosmic story. Level 48. Galaxy Clusters. Zoom out far beyond the Local Group, and you enter the realm of galaxy clusters, vast gatherings of hundreds, sometimes thousands, of galaxies bound tightly by gravity. These colossal structures are the largest gravitationally bound objects in the universe, forming massive cities of stars scattered across millions of light years. Between the galaxies lies a mysterious substance called dark matter, invisible but detectable because its gravity holds these clusters together like an invisible glue. Dark matter makes up most of the cluster's mass and shapes how galaxies move within them. Inside these clusters, galaxies can interact and sometimes collide, causing bursts of star formation and dramatic transformations. The sheer scale of these clusters is mind-boggling. Entire galaxies zoom around each other like cosmic dancers, all drifting through an enormous, mostly unseen ocean of dark matter. Studying galaxy clusters helps astronomers understand the universe's structure, the nature of dark matter, and how galaxies evolve in crowded environments. They're cosmic cities on a scale so vast it challenges our imagination, reminding us of the intricate web that connects everything in the universe. Level 49. Filaments and Voids. As we explore even further out into the universe, a breathtaking pattern emerges: the cosmic web. Galaxies do not spread randomly through space. Instead, they connect in long, thin threads called filaments. These filaments stretch across billions of light years, weaving a vast network that shapes the universe's large-scale structure. Between these filaments are enormous voids, empty regions hundreds of millions of light years wide, with almost no galaxies at all. This structure is the universe's skeleton, a grand design born from the Big Bang and sculpted by gravity over billions of years. The cosmic web's filaments act like superhighways for galaxies and matter, guiding their motion through the universe. Meanwhile, the vast emptiness of the voids highlights how much space is truly empty. This delicate balance between dense clusters and enormous gaps is a fingerprint of the universe's origins and evolution. The cosmic web connects everything, revealing the universe's incredible scale and complexity. a vast network woven across the darkness, linking galaxies in an endless, silent dance. Level 50, the cosmic web, universe's skeleton. Imagine stepping outside the universe and looking down upon its vast structure. You would see an immense cosmic web stretching out in every direction, galaxies lined up like beads on long, glowing strings. These filaments cross and intersect, forming nodes where galaxy clusters gather. Between these threads lie enormous, dark voids, vast empty spaces almost entirely devoid of matter. This cosmic web is the universe's skeleton, the large-scale structure that shapes everything we see in the cosmos. It is not random chaos, but a carefully woven tapestry shaped by gravity and dark matter since the universe's earliest moments. The expansion of the universe pushes galaxies apart, but gravity pulls them together along these filaments, creating a dynamic, ever-changing cosmic landscape. This structure is the stage on which all cosmic events unfold, from star formation to galaxy collisions. Understanding the cosmic web gives us a glimpse into the fundamental workings of the universe and its past, present, and future. It's the invisible framework holding all existence in balance, a majestic and mysterious blueprint stretching across the cosmos. Level 51. What is a black hole? Imagine compressing something incredibly massive, a star many times bigger than our sun, into an infinitely small point. This is a black hole. It forms when a massive star exhausts its fuel and collapses under its own gravity, squeezing itself into a tiny, dense spot called a singularity. Around this point lies the event horizon, a boundary where gravity becomes so strong that nothing can escape, not even light. This is why black holes appear completely dark and invisible. Black holes challenge the laws of physics as we know them. Inside a black hole, time and space behave in ways that are hard to imagine. Gravity is so intense, it warps space-time itself, bending light and pulling everything inward. Scientists can't observe black holes directly, but detect them by studying how stars and gas move near these invisible monsters. Black holes aren't cosmic vacuum cleaners constantly sucking everything in. They only pull in matter that comes too close. Black holes exist in all sizes, from tiny ones formed by collapsing stars to supermassive black holes millions or billions of times heavier than the sun, lurking at galaxy centers. They are some of the universe's most mysterious and powerful objects, revealing the extreme nature of gravity and space. 52. Event horizons, the point of no return. Every black hole has a boundary called the event horizon. This invisible line marks the ultimate point of no return. Once anything, matter, light, or even information, crosses this boundary, it can never escape. The gravitational pull inside the event horizon is so strong that escape velocity exceeds the speed of light, making it impossible to break free. From the outside, objects falling toward a black hole appear to slow down dramatically as they near the event horizon. Their light stretches and dims, seeming to freeze in time, trapped at the edge. This is because gravity distorts time itself near the event horizon, a phenomenon predicted by Einstein's theory of general relativity. Time moves slower in strong gravitational fields, so an observer far away sees falling objects slow, almost frozen. The event horizon hides the black hole's singularity, where densities become infinite and physics breaks down. This boundary is crucial for understanding black holes because it separates our universe from a region we cannot access or see. It acts as a cosmic veil, hiding some of the universe's most profound mysteries and pushing scientists to explore new physics beyond the horizon. 53. Spaghettification. Torn by gravity. If you were to fall feet first into a black hole, you would experience an extreme and terrifying effect called spaghettification. This happens because gravity near a black hole isn't uniform. Your feet would feel a much stronger gravitational pull than your head, stretching your body vertically like a piece of spaghetti. This stretching occurs due to tidal forces, the difference in gravity between 2 points. Spaghettification isn't just stretching. It eventually pulls atoms apart, tearing your body into a long, thin strand. Despite this violent fate, you would continue falling deeper into the black hole, unable to resist the intense gravity. The process illustrates how black holes warp space and matter beyond what we experience on Earth. This phenomenon shows gravity's raw, destructive power in extreme conditions. While spaghettification is a fate no human could survive, it helps scientists understand how gravity works in regions where normal physics fails. It's a reminder that black holes are not only invisible, but also places where the rules of reality themselves are bent and broken. 54. Time dilation. Time slows. Near gravity. Time is not absolute. Its flow changes depending on the strength of gravity. Near a black hole, gravity is so intense it warps time itself, causing a phenomenon called time dilation. This means time slows down near the black hole's event horizon compared to someone far away in weaker gravity. Imagine standing near the edge of a black hole. For you, time would seem to pass normally, but to an outside observer, your movements would slow dramatically. Minutes for you might stretch into years for someone watching from afar. This strange effect is a consequence of Einstein's theory of general relativity, which describes gravity as the bending of space-time. Time dilation has been observed near Earth with precise clocks, but near a black hole, the effect is extreme. It challenges our common sense and reveals that time is flexible, woven into the cosmic fabric affected by mass and energy. This bending of time near black holes forces us to rethink what we know about reality and the universe. 55. Wormholes, shortcuts through space. Imagine folding a piece of paper so that 2 dots on opposite ends touch instantly. This is the idea behind a wormhole, a theoretical tunnel through space-time that could connect distant parts of the universe, or even different times. Wormholes arise from solutions to Einstein's equations, but remain hypothetical, never directly observed. If wormholes exist and are stable, they could provide shortcuts, allowing travel across vast cosmic distances instantly, or even enabling time travel. However, such tunnels would require exotic matter with unusual properties to keep them open. Scientists debate whether these conditions can exist naturally. Wormholes capture the imagination, blending science with science fiction. They challenge our understanding of space, time, and causality, hinting at a universe far stranger than we realize. Although purely theoretical, wormholes inspire research in quantum gravity and cosmology, pushing boundaries of physics and the possibility of interstellar travel. They represent the ultimate cosmic shortcut, a gateway to the unknown. 56. White holes, time in reverse. If black holes are cosmic traps pulling everything in, white holes are their mysterious theoretical opposites, cosmic fountains that only spew matter and energy out, but never let anything enter. White holes are predicted by some solutions to Einstein's equations, but have never been observed. They could represent the other side of a black hole, possibly connected through wormholes, acting as an exit point for matter that falls into a black hole elsewhere. Imagine a white hole as a reverse black hole, spewing light, matter, and information into space instead of swallowing it. Some physicists speculate white holes could explain certain high-energy cosmic phenomena, or even be linked to the birth of our universe. They remain purely hypothetical because no observational evidence supports their existence yet. White holes challenge our understanding of time and causality, implying time might flow backward in their vicinity. They raise questions about whether black holes and white holes could form a cosmic loop, recycling matter and energy through space-time. Though still in the realm of theory, white holes remind us that the universe may hold surprises beyond our current reach, where time and space twist in unimaginable ways. 57. Hawking radiation. Black holes can shrink. Stephen Hawking revolutionized black hole physics by predicting that black holes aren't completely black. They emit faint radiation, now known as Hawking radiation. This radiation results from quantum effects near the event horizon, where particle-antiparticle pairs pop in and out of existence. Occasionally, one particle falls into the black hole while the other escapes, causing the black hole to lose tiny amounts of energy. Over billions of years, this slow leakage of energy could cause black holes to shrink and eventually evaporate completely, leaving behind only empty space. This discovery connected quantum mechanics, gravity, and thermodynamics in a way never before imagined. Hawking radiation challenges the idea that nothing can escape a black hole and opened new fields of research about black hole thermodynamics and information loss. It suggests black holes have temperatures and entropy, behaving more like physical objects than just cosmic vacuum cleaners. This prediction remains difficult to observe directly because the radiation is incredibly weak for large black holes. But it fundamentally changed how scientists view black holes, not as eternal prisons, but as evolving cosmic entities with life cycles. 58. Quantum foam, space at the smallest scale. At the tiniest scales imaginable, far smaller than atoms or even subatomic particles, space itself is not smooth and empty, but frothy and turbulent. This churning, dynamic nature of space-time is called quantum foam. According to quantum mechanics, energy fluctuations constantly produce particles that appear and vanish almost instantly, creating a foamy, bubbling texture to the fabric of reality. Quantum foam suggests that the universe, at its most fundamental level, is wild and unpredictable. Time and space ripple and fluctuate, defying classical physics. This microscopic chaos might hold clues to uniting quantum mechanics and gravity into a single theory, something physicists call quantum gravity. The idea of quantum foam paints a picture of the universe's skeleton, not solid and static, but alive with activity, where space and time themselves jitter and sparkle. Understanding this quantum foam is essential for probing the origin of the universe and the nature of black holes, where quantum effects dominate. Though invisible to us, quantum foam shapes the deepest mysteries of existence, whispering secrets about the universe's ultimate nature and its birth from the Big Bang. 59. Singularities. Infinite density. At the core of a black hole lies a singularity, a place where matter is crushed to infinite density, and the laws of physics as we know them break down completely. In a singularity, space and time lose meaning, and gravitational forces become infinitely strong. This point of infinite curvature is hidden behind the event horizon, inaccessible to outside observers. Singularities represent the limits of our understanding of the universe. They challenge both general relativity, which predicts their existence, and quantum mechanics, which cannot yet fully describe them. Resolving what happens at singularities is one of the greatest quests in modern physics. Some theories suggest that singularities might be replaced by exotic states of matter or quantum gravitational effects that prevent true infinities. Others speculate that singularities could be gateways to other universes or new regions of space-time. But these ideas remain speculative. Despite being hidden, singularities hold the key to understanding the birth of black holes, the beginning of the universe itself, and possibly the true nature of reality, making them one of the most profound and mysterious features in all of science. 60. Are black holes gateways? What if black holes aren't just cosmic endpoints but doors to other worlds? Some physicists propose that black holes might be gateways or tunnels to other parts of the universe, or even to entirely different universes. This idea is based on certain solutions in Einstein's equations, suggesting black holes could connect distant points in space-time through wormholes. If true, black holes might allow travel across vast cosmic distances instantly, or provide a bridge between different realities. However, this remains highly speculative. The extreme gravity and unknown physics inside black holes make it unclear whether anything could survive such a journey. Black holes challenge our deepest assumptions about space and time, forcing us to ask where the universe ends and what lies beyond. They blur the lines between science and science fiction, inspiring questions about the possibility of parallel universes and the multiverse. While we may never know for sure, the idea that black holes could be cosmic gateways expands our imagination and pushes science toward new horizons, reminding us that the universe is stranger and more mysterious than we can ever fully grasp. 61. What is light? Light is one of the most fascinating and mysterious phenomena in the universe. It behaves both as a particle and a wave, a concept known as wave-particle duality. Light consists of tiny particles called photons, but it also travels in waves that ripple through space. Even though light has no mass, it carries energy and moves at the incredible speed of approximately 186,000 miles per second, or about 300,000 kilometers per second, which is the fastest speed possible in the universe. Light is what enables us to see everything around us, from the smallest details to the vast expanse of stars and galaxies in the night sky. When you look up at the stars, you are actually seeing light that has traveled for many years, sometimes millions or even billions of years, to reach your eyes. This means that every ray of light is like a messenger, bringing us information from the past, from distant parts of the universe. Without light, there would be no way to perceive the world or the cosmos. It carries not just brightness, but stories. Stories about the history and evolution of everything we know. 62. Light years and time. A light year is a unit of distance used in astronomy, and it often causes confusion because the word year makes people think it measures time. However, a light year measures how far light travels in 1 year. Since light moves at about 186,000 miles per second, in a year, it travels roughly 6 trillion miles, about 9.5 trillion kilometers. This vast distance helps astronomers describe the immense spaces between stars and galaxies. When we say a star is 10 light years away, it means that the light we see from that star today actually left it 10 years ago. This is like looking into a cosmic time machine. The farther away an object is, the older the light we see from it, showing the star or galaxy as it was long ago. This is why astronomers say that looking at the night sky is like looking back in time. This incredible property of light helps us understand the universe's history. By studying light from distant objects, we learn about the early universe, the formation of stars and galaxies, and the evolution of cosmic structures over billions of years. 63. Redshift and blueshift. Redshift and blueshift are important concepts that help astronomers understand the movement of galaxies and other celestial objects. When a galaxy moves away from us, the light it emits stretches out, shifting toward the red part of the spectrum. This effect is called redshift. It's similar to the Doppler effect we hear with sound, like when an ambulance siren lowers in pitch as it drives away. The stretching of light waves toward red shows that the universe is expanding, and the galaxies are moving farther apart over time. On the other hand, when a galaxy moves closer to us, its light waves compress and shift toward the blue end of the spectrum. This is called blueshift. Although less common on a large scale, blueshift is observed in some nearby galaxies heading our way. By measuring these shifts, astronomers can calculate how fast galaxies are moving and in which direction. This helps us understand the expansion of the universe, its age, and its ultimate fate. Redshift in particular played a key role in the discovery that the universe is not static, but constantly growing. 64. Special relativity. Einstein's theory of special relativity revolutionized physics by revealing that space and time are connected in a four-dimensional fabric called space-time. Before Einstein, time was thought to be absolute, always ticking the same for everyone, everywhere. But special relativity showed that time is relative and depends on how fast you are moving. According to this theory, the faster you move through space, the slower time passes for you compared to someone standing still. This effect, known as time dilation, means astronauts traveling close to the speed of light would age more slowly than people on Earth. Mass also increases with speed, making it harder to accelerate as you approach light speed. At the speed of light, time would theoretically stop. Special relativity isn't just theoretical. It has been confirmed by many experiments and is essential in technologies like GPS satellites, which must account for time differences caused by their speeds and gravity. This theory challenges our everyday experience and shows how the universe operates on a deeper, stranger level than we can easily imagine. 65. Time as a dimension. Time is often thought of as invisible and intangible, but in physics, it is a real dimension. Just like the three dimensions of space, up, down, left, right, forward, backward, we move through space freely, but through time, we always move forward at a steady pace, 1 second per second. Unlike spatial dimensions, we cannot move backward in time, nor can we stop it. Every moment passes, and time connects all events in an ongoing flow that shapes our experiences and the universe's history. This constant movement through time is fundamental to change, growth, and life itself. Physicists treat time as the fourth dimension, making up a unified fabric called space-time. This concept helps explain gravity and the structure of the universe, especially in Einstein's theory of relativity, where space and time influence each other. Without time, the universe would be frozen in place, with no motion, no change, and no life. Time gives meaning to existence, marking the sequence of events and allowing us to experience the unfolding story of reality. 66. The speed of light, cosmic speed. Limit. Nothing in the universe can travel faster than light. This isn't just a random fact. It's a fundamental cosmic rule. Whether it's a speeding rocket, a radio signal, or even the fastest thought you can imagine, none can surpass the speed of light, which is roughly 186,000 miles per second. Light is the ultimate speed limit. Why is this speed so important? Because going faster than light would mean something truly strange. It would allow you to travel backward in time. This would break everything we know about cause and effect, creating paradoxes where causes could happen after effects. So far, nature has never allowed anything to break this speed barrier. It's like an invisible fence keeping reality consistent. Light leads the way in the cosmos. Every particle, wave, or object with mass must follow behind this speed limit. This limit shapes how the universe operates, from the way stars shine to how galaxies move, and how we experience time itself. It's an unbreakable cosmic law, quietly holding the fabric of reality together. 67. The twin paradox. Imagine two twins. One stays on Earth, living an ordinary life. The other blasts off in a spaceship, traveling near the speed of light, then returns home after many years. When they reunite, something incredible happens. The traveling twin is younger than the one who stayed behind. This strange effect is called the twin paradox. It's a direct consequence of Einstein's theory of relativity. Time itself slows down for someone moving close to the speed of light, compared to someone at rest. This isn't science fiction. It's real and measurable. The faster you move, the slower your time flows relative to others. For the traveling twin, time stretches out and slows, so they age less. Meanwhile, the earthbound twin experiences normal time. This paradox shows how motion can bend time, changing our very experience of life's passage. It's a mind-bending truth that challenges our everyday sense of time and reveals the deep connection between space, speed, and time. 68. Space-time curves. Think of space-time like a giant rubber sheet stretched out flat. When you place a heavy ball on it, the sheet curves and bends under the weight. This bending is what we call gravity. Massive objects like stars, planets, and black holes curve the fabric of space-time around them. Other objects don't get pulled by an invisible force. Instead, they follow the curves and dips in this bent space-time. For example, Earth orbits the Sun, not because it's being pulled in a straightforward way, but because it's rolling along a curved path created by the Sun's mass. This idea was one of Einstein's greatest insights. Gravity is geometry. It's the shape of space and time themselves that tells matter how to move. This explains orbits, free falls, and even how light bends near massive objects. Space-time curves create the cosmic dance that governs the movement of everything in the universe, linking space and time into one elegant bending fabric. 69. Gravitational lensing. Light usually travels in a straight line. But when it passes near a massive object, like a galaxy or black hole, gravity bends its path. This effect is called gravitational lensing. Gravity acts like a giant magnifying glass, warping and bending light rays. Because of this, we can see objects that would normally be hidden behind massive stars or galaxies. The light bends around the massive body, making distant galaxies appear stretched, brighter, or multiplied. This cosmic lens lets astronomers peer much deeper into space, revealing galaxies billions of light years away that would otherwise be invisible. It's like the universe has its own natural telescope. Gravitational lensing doesn't just help us see farther, it also confirms Einstein's theory that gravity warps space-time, and even light itself. Through these cosmic lenses, we get glimpses of the distant past, uncovering secrets about the early universe. 70. Time travel. Possible? Time travel has fascinated humans for centuries. Is it really possible to move through time like we move through space? Relativity shows us that we already experience a kind of time travel, always moving forward, 1 second at a time. Near massive objects or at very high speeds, time slows down relative to others. So, in a way, astronauts or people near black holes experience time differently than we do on Earth. But what about traveling backward in time? That's far trickier and more uncertain. Some theories suggest wormholes, cosmic tunnels through space-time, might allow shortcuts not just across space, but through time itself. But these ideas are highly speculative. Wormholes might collapse or destroy anything trying to pass through. The universe is full of strange, mysterious rules. It allows weird possibilities, but it also keeps its biggest secrets close. Whether backward time travel is possible remains one of science's greatest open questions, waiting to be solved. 71. The Big Bang. In the beginning, there was nothing. No space, no time, no matter, no light. Imagine a complete void, utterly empty. Then, in an instant, everything changed. A single moment sparked it all. Energy burst into existence, particles formed, and space itself began to expand. This moment is what we call the Big Bang. But it wasn't a loud explosion like a bomb going off. Instead, it was more like a quiet breath, a subtle beginning to everything we know. Space started stretching out, carrying matter and energy with it, setting the stage for galaxies, stars, and planets. Time and space, once non-existent, came into being at that moment. The universe has been growing ever since, expanding continuously and cooling down, slowly turning chaos into order. This expansion shapes the cosmos we see today, from nearby stars to distant galaxies billions of light years away. The Big Bang is the origin story of everything, our cosmic beginning. It's the ultimate starting point, a moment when everything emerged from nothing, beginning a journey that continues even now, billions of years later. 22. Cosmic background radiation. The Big Bang left behind a faint, ancient glow that fills the entire sky, known as the cosmic microwave background, CMB. Think of it as a whisper from the earliest moments of the universe, around 380,000 years after the Big Bang itself. Before the first stars or galaxies formed, the universe was a hot, dense soup of particles and light. As the universe expanded and cooled, light was finally able to travel freely through space, creating this background radiation. The CMB is like a baby picture of the universe, an echo from the past that tells us what the cosmos looked like when it was still very young. It's almost perfectly uniform, but has tiny variations that reveal the seeds of galaxies and clusters. By studying this glow, scientists have learned about the universe's age, composition, and shape. The cosmic background radiation is a silent message, a fossil light from the dawn of time, still shining across the vast emptiness of space. 73. Inflation theory. Just moments after the Big Bang, the universe didn't simply grow steadily. It underwent a sudden and incredible expansion called inflation. During inflation, space itself stretched outward faster than the speed of light, a mind-blowing burst that shaped everything that followed. Imagine the universe starting smaller than a single atom. Then, in less than a trillionth of a second, it ballooned to the size of a galaxy. This rapid inflation smoothed out the universe, making it appear uniform and flat on large scales. Inflation explains why the cosmos looks so even, yet also contains tiny ripples that would later grow into galaxies, stars, and planets. It set the stage for the universe's structure and the distribution of matter. Though invisible to us now, inflation left clues in the cosmic microwave background radiation and the arrangement of galaxies. It's one of the most important concepts in cosmology, revealing how the universe transformed from a tiny speck to the vast expanse we live in today. 74. First stars and galaxies. For hundreds of millions of years after the Big Bang, the universe was dark and quiet. No stars shone, no galaxies existed yet. Instead, vast clouds of hydrogen gas drifted through space, floating silently in the darkness. Gravity began to work its magic, pulling these clouds of gas together. As they grew denser and hotter, the first stars ignited, massive, bright, and fierce. These first stars burned hot and fast, lighting up the darkness and creating the first building blocks of galaxies. Over time, these stars gathered into groups, forming the earliest galaxies. The night sky began to glow with their light, ending the cosmic dark ages and starting a new chapter of cosmic evolution. These early stars created the heavier elements that would one day become planets, life, and everything around us. The birth of the first stars and galaxies is the universe's grand awakening. Its first light after the long night. 75. The expanding universe. The universe is constantly growing. Every galaxy is moving away from every other galaxy. It's as if space itself is stretching out, causing the distance between galaxies to increase every second. This expansion doesn't happen because galaxies are flying through space away from each other. Instead, the fabric of space itself is expanding, like a balloon inflating from the inside. Imagine dots on the balloon's surface moving apart as the balloon grows larger. This is how galaxies move apart in the universe. The universe isn't expanding into anything. It is the expansion of space itself. This discovery, first made by Edwin Hubble in the 1920s, changed our understanding of the cosmos forever. As space expands, the light from distant galaxies stretches, making it appear redder, a clue that the universe has been expanding for billions of years and will likely keep growing for the foreseeable future. 76. Hubble's discovery. In 1929, the astronomer Edwin Hubble changed our understanding of the universe forever. By carefully observing distant galaxies through powerful telescopes, he noticed a surprising pattern. The farther away a galaxy was, the faster it seemed to be moving away from us. This discovery was revolutionary because it meant the universe wasn't static or unchanging, as many scientists had thought. it was expanding. Imagine the universe as a giant balloon with dots drawn on it, representing galaxies. As the balloon inflates, every dot moves farther away from each other. Hubble's observation was just like seeing those dots move apart as the balloon grows. This expansion means the universe itself is stretching, and everything inside it is drifting away from everything else. Hubble's discovery supported the Big Bang theory, which says the universe began from a tiny, hot, dense point and has been expanding ever since. His work gave scientists a new way to understand cosmic history, showing that space and time are dynamic and constantly changing. Today, the Hubble Space Telescope continues his legacy, helping us explore the vast, expanding cosmos. 77. Age of the universe. How old is the universe? Scientists have answered this question by studying the light traveling from the farthest reaches of space and analyzing faint signals left over from the Big Bang. Using measurements of cosmic expansion, the composition of galaxies, and the cosmic microwave background radiation, researchers have estimated that the universe is about 13.8 billion years old. This number tells a profound story. It means that everything we see, from stars to galaxies to the very atoms in our bodies, has a shared history stretching back nearly 14 billion years. Even Earth itself, about 4.5 billion years old, is relatively young in this grand timeline. Despite this vast age, the universe is still considered young compared to what might lie ahead. Billions of years may pass, but the cosmos continues evolving, forming new stars, galaxies, and perhaps even life on distant planets. Knowing the universe's age connects us to a cosmic story bigger than ourselves, reminding us that we live in an ever-changing, ancient universe filled with mysteries yet to be discovered. 78. The Big Freeze. Cold, dark future. Imagine a future where the universe never stops expanding. As it stretches, galaxies will drift farther apart, growing isolated in a vast emptiness. Over trillions of years, stars will burn out their fuel and fade away, leaving behind cold remnants like white dwarfs, neutron stars, and black holes. Even black holes, once thought eternal, slowly lose energy through a process called Hawking radiation, eventually evaporating into nothing. As matter decays and energy spreads thinly across ever-expanding space, the universe will grow colder and darker. This slow, inevitable fading is called the Big Freeze. In this far-off future, temperatures approach absolute zero, meaning no heat, no light, and no life can survive. The cosmos will be silent and still, a frozen landscape where the ticking clock of time continues, but nothing happens. Though the Big Freeze might seem bleak, it's a natural consequence of cosmic expansion and energy conservation. It marks the final, eternal stage of the universe's journey, an endless night of silence and cold. 79. The Big Crunch. A reversal. While many believe the universe will expand forever, some theories propose a different fate, the Big Crunch. What if, instead of expanding endlessly, the universe's growth slows and reverses? Gravity might eventually pull everything back together. In this scenario, galaxies, stars, and planets would move closer and closer, colliding and merging. The universe would become hotter and denser, compressing matter into an unimaginably small volume. Space itself would contract, folding back into a dense point. This cosmic reversal would be the opposite of the Big Bang. It might end with the entire universe collapsing into a singularity, a state of infinite density where our current laws of physics break down. Some scientists speculate that the Big Crunch could lead to a new Big Bang, a rebirth of the cosmos in a never-ending cycle of expansion and contraction. Although current observations favor continual expansion, the Big Crunch remains a fascinating possibility that challenges our understanding of the universe's destiny. 80. The heat, death of the universe. The most widely accepted theory about the universe's final fate is the heat death. Unlike dramatic cosmic collisions or explosive endings, heat death is quiet, slow, and inevitable. As stars burn out and galaxies move apart, the universe's available energy will spread evenly throughout space. Without energy differences, no work can be done. No chemical reactions, no movement, no life. This state of maximum entropy means the universe becomes a cold, dark, and lifeless place. Heat death represents thermodynamic equilibrium, where everything has reached balance and change no longer occurs. Particles will be scattered thinly, drifting through a vast emptiness with no chance of regrouping. Though this ending is peaceful, it is also permanent. The universe will drift in an eternal state of rest, a cosmic graveyard where time continues but nothing new happens. It's the ultimate destiny of a universe that started with a fiery birth, now fading quietly into the darkness. 1. What is dark matter? Everything we see in the universe, stars, planets, gas clouds, and galaxies, makes up only about 5% of what exists. The rest is invisible and mysterious, known as dark matter. Dark matter does not emit, absorb, or reflect light, so we can't see it directly. Despite being invisible, it plays a crucial role in shaping the universe. Scientists first suspected dark matter because galaxies spin much faster than their visible matter can hold together. Without something extra pulling them inward, stars would simply fly off into space. Dark matter acts like an invisible web or glue, holding galaxies and galaxy clusters together. It also influences the formation and movement of cosmic structures on a massive scale. Though we don't know what dark matter is made of, it could be composed of unknown particles that interact weakly with ordinary matter. Detecting these particles is one of the biggest challenges in physics today. Understanding dark matter could help us unlock deep secrets about the universe's origin, structure, and fate. Even though we cannot see it, dark matter's gravitational pull is a powerful reminder that most of the universe remains hidden and waiting to be discovered. 82. Evidence for dark matter. How do we know dark matter exists if we can't see it? The answer lies in its gravitational effects. When scientists observe galaxies, they notice something strange. The stars orbit their galactic centers too fast to be held by visible matter alone. According to the laws of physics, these galaxies should tear themselves apart. But they don't. This suggests there is some invisible mass adding extra gravity. Clusters of galaxies also behave mysteriously. When galaxies collide, or groups of galaxies move, the visible matter alone can't explain the gravitational forces at work. Dark matter is the unseen hand controlling these motions. Astronomers use special tools like gravitational lensing, where light from distant objects bends around massive unseen matter. This bending effect reveals the presence of dark matter, even though we can't see it directly. Despite decades of searching, dark matter particles remain elusive. We can feel their gravity, but catching one in a detector has been extremely difficult. This invisible substance shapes the cosmos, but its true nature remains one of the greatest mysteries of modern science. 83. What is dark energy? If dark matter is the universe's invisible glue, then dark energy is its mysterious engine pushing everything apart. Unlike dark matter, which pulls things together with gravity, dark energy causes the expansion of the universe to speed up. It is a strange force, woven into the very fabric of space itself. Dark energy makes up about 68% of the total energy in the cosmos, dominating the universe's future. Scientists first discovered it in the late 1990s when observing distant supernova explosions. These supernovae were dimmer than expected, meaning the universe's expansion was accelerating rather than slowing down. No one knows exactly what dark energy is. Some think it could be a property of empty space, a kind of energy that fills the vacuum. Others believe it could be a new form of energy, or a sign that our understanding of gravity is incomplete. This mysterious force shapes the fate of the universe, driving galaxies farther apart and making space itself stretch. Dark energy reveals that most of the universe is something we cannot see or fully understand, a dark force dominating everything around us. 84. The accelerating universe. For many years, scientists believed that after the Big Bang, the expansion of the universe would gradually slow down due to gravity pulling everything back together. But in 1998, astronomers made a shocking discovery. The universe isn't slowing down, it's speeding up. Galaxies are moving away from each other faster and faster over time. This acceleration means the universe is stretching in ways we never imagined. The force behind this speeding expansion is dark energy, a mysterious and invisible energy that fills all of space. It's pushing galaxies apart against gravity's pull. As the universe expands, galaxies will eventually become isolated from each other, disappearing from view. The night sky will grow darker as distant galaxies vanish beyond our reach. This accelerating expansion suggests the universe could expand forever, becoming colder and emptier. Understanding why the universe is accelerating is one of the biggest challenges in physics today. It raises deep questions about the nature of space, time, and the forces that govern everything we see. The accelerating universe shows us how strange and surprising the cosmos can be. 85. Neutrinos, ghost particles. Neutrinos are tiny, nearly invisible particles that flood through the universe and through you every second. Trillions of them pass through your body without you ever feeling a thing. They're called ghost particles because they rarely interact with matter, making them incredibly difficult to detect. Neutrinos have almost no mass and travel near the speed of light. They are produced in massive quantities by the sun, exploding stars, and other cosmic events. Despite their abundance, they can pass through entire planets, stars, and even humans almost completely unhindered. Scientists study neutrinos to understand the processes inside the sun and other stars. Neutrinos carry information about these distant events, making them cosmic messengers. Detecting neutrinos requires huge underground detectors, shielded from other radiation. These experiments have helped reveal that neutrinos have mass, a discovery that challenged long-held beliefs in physics. Though tiny and elusive, neutrinos are essential to understanding the universe's fundamental workings. 86. Antimatter. In the vast universe, every particle of matter has a mysterious twin called antimatter. Antimatter particles have the same mass as normal particles, but opposite charges. For example, the antimatter twin of an electron is called a positron. When matter and antimatter meet, they annihilate each other in a burst of energy, releasing light and other particles. This process is so powerful that it's considered one of the universe's most energetic events. Scientists believe that during the Big Bang, equal amounts of matter and antimatter were created. But if that were true, all matter should have been destroyed, leaving a universe filled only with energy. Yet here we are, an entire cosmos made of matter. This mystery is called the matter-antimatter asymmetry problem. Somehow, a tiny imbalance favored matter over antimatter, leaving just enough to build stars, planets, and life itself. Understanding why this imbalance happened is a key quest in modern physics. Experiments at particle accelerators, like the Large Hadron Collider, try to recreate conditions of the early universe to uncover why matter won. Antimatter's existence is not just a curiosity. It's a clue to why we exist at all. 87. Quantum fields. At the deepest level, everything in the universe is not made of solid objects, but of invisible energy fields stretching across all space. These are called quantum fields. Electrons, protons, quarks, all the particles that form matter, are actually ripples or vibrations in these fields. When the fields vibrate at certain energies, particles appear, like waves rising on a vast ocean. This idea changes how we understand reality. Instead of tiny solid bits, matter is more like energy shaped temporarily into particles. These vibrations can pop in and out of existence, showing how strange and dynamic the quantum world really is. You and everything around you are made of these quantum fields. Your body's atoms are patterns of vibrating energy, constantly shifting, but still stable enough to form life. This view shows the universe as a beautiful symphony of energy waves, where matter is just a fleeting dance of vibrations, not static things. Quantum fields reveal that the universe is more mysterious and interconnected than our senses ever imagined. 88. Multiverse theory. Imagine our universe is just one bubble in an endless cosmic ocean. This idea, called the multiverse theory, suggests that there could be countless other universes beyond our own. Each might have different laws of physics, dimensions, or even versions of reality. In some universes, time could flow differently. In others, life might never have formed. This theory arises from interpretations of quantum mechanics and cosmic inflation models, which hint that our universe might be part of a much larger multiverse. If true, it means every possible outcome, choice, or event could happen somewhere else in a parallel universe. Some multiverses might be completely unreachable, forever hidden from us. Others could be radically different, with strange forms of matter, energy, or life. This idea stretches our imagination and challenges what we think of as reality, though it may sound like science fiction. The multiverse could explain why our universe's physical constants are so finely tuned for life. We might be just one of many cosmic possibilities. 89. Simulation theory. What if everything we experience, the stars, Earth, even our own thoughts, is part of an elaborate computer simulation? The simulation theory proposes that an advanced civilization, far more technologically powerful than us, could create a digital universe so detailed that its inhabitants believe it's real. Some scientists and philosophers take this seriously because technology is advancing fast. In the future, we might be able to simulate entire worlds with conscious beings inside them. If that's possible, how can we be sure we aren't already inside such a simulation? This theory raises deep questions. What is reality? Is matter real or just data? Could our universe be a digital construct running on some cosmic computer? While simulation theory can't yet be proven or disproven, it challenges how we think about existence, consciousness, and the nature of reality itself. Whether true or not, it shows how technology and philosophy blend when asking the universe's biggest questions. Are we holograms? Some scientists believe the universe might work like a gigantic hologram, a three-dimensional image projected from information encoded on a distant, two-dimensional surface. This idea, called the holographic principle, suggests that everything we see, feel, and experience in 3 dimensions could actually be a shadow of information stored elsewhere. Imagine a movie playing on a flat screen, but the characters seem fully 3D and real. Similarly, our reality might be a projection from a lower dimensional boundary at the edge of the universe. If true, this means space, time, and matter are emergent phenomena, not fundamental. You yourself might be a 3D shadow of a deeper 2D reality. This radical idea comes from attempts to unify gravity and quantum physics. While it sounds like science fiction, the holographic principle has mathematical support and helps solve some paradoxes in physics. It suggests reality is far stranger than everyday experience, and that the universe's true nature might be hidden in an unexpected form. 91. Could life exist elsewhere? Look up at the sky, and you see countless stars, each possibly with planets circling them. It's hard to imagine that Earth is the only place in the universe where life exists. Scientists have found water, which is essential for life as we know it, on moons and planets far away. Organic molecules, the basic building blocks of life, have been detected drifting through space, riding on comets and asteroids. These findings suggest that the ingredients for life might be common across the universe. But despite all these clues, we haven't yet found any clear signs of life beyond Earth. No radio signals, no spaceships, no unmistakable messages from other civilizations. The universe remains silent in that regard. This silence makes the question even more puzzling. Are we truly alone? Or could life exist in forms that are very different from what we understand? Could it be hiding deep beneath ice, or in strange environments we've barely begun to explore? The search for life elsewhere drives astronomers and scientists to keep looking, hoping that one day we might discover that the universe is not just a vast emptiness, but a cosmic neighborhood full of surprises. 92. Extremophiles. Life in harsh places. Life on Earth is incredibly tough. Some living things, called extremophiles, survive in the most extreme and hostile environments you can imagine. They thrive in boiling acid pools, frozen deserts, deep under the ocean where there's no light, and even inside radioactive rocks. These creatures prove that life is more adaptable than we once thought. If life can exist in these harsh places on Earth, then it might be able to survive on other worlds, too. For example, Jupiter's moon Europa and Saturn's moon Enceladus have thick layers of ice covering oceans beneath their surfaces. These oceans might be warm enough to support microbes warmed by tidal forces from their planets. Even the thick clouds of Venus or the high atmosphere of gas giants could harbor some form of life. The study of extremophiles expands our understanding of what life needs to survive. It pushes scientists to search beyond Earth's habitable zone and consider places we once thought impossible. It suggests that life could be hiding in the most surprising places in our solar system and beyond. 93. The Drake Equation. The question, how many intelligent civilizations might exist in our galaxy, is huge and complicated. The Drake Equation was created to estimate this number by combining several important factors. It looks at how many stars form. How many of those stars have planets? How many planets could support life? How many of those might develop intelligent beings? And how many civilizations might be able to communicate? Each factor in the equation is uncertain, so the results can vary wildly. Sometimes the answer could be 0, sometimes it could be millions. The equation doesn't give a definite answer, but helps guide scientists in their search for extraterrestrial intelligence. Even with the uncertainty, the Drake Equation is useful because it breaks a big mystery into smaller parts that we can study. It inspires researchers to learn more about exoplanets, the conditions needed for life, and how intelligence might arise. While we don't have a final answer yet, the equation keeps us hopeful that somewhere out there, other minds might be looking up at their night skies, wondering the same things we do. 94. The Fermi Paradox. If there are many intelligent civilizations in the universe, why haven't we seen or heard any signs of them? This question is called the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" There are many possible explanations. Maybe civilizations destroy themselves before they develop space travel or communication technology. Maybe they choose to stay quiet, avoiding contact. They could be so far away that their signals haven't reached us yet. Or, it's possible, intelligent life is extremely rare, and we might be among the first. The paradox reminds us that the universe is full of mysteries, and that silence doesn't necessarily mean we are alone. It challenges scientists to think about what advanced civilizations might be like and how they might behave. It also encourages us to keep searching, exploring new ideas and technologies that might help us finally answer this profound cosmic question. 95. SETI. The search for signals. For decades, humans have used radio telescopes to scan the skies in search of messages from alien civilizations. This effort is known as SETI, the search for extraterrestrial intelligence. Scientists listen for unusual patterns or signals that might be attempts to communicate across the vastness of space. We've also sent our own messages into space. For example, the Voyager spacecraft carried golden records filled with sounds from Earth, music, greetings, and natural sounds like rain and laughter. These records are like time capsules, hoping that someday someone, somewhere, will find them. So far, we haven't received any confirmed replies or signs of intelligent life. The silence is puzzling, but doesn't discourage the search. SETI continues to improve its technology, listening more carefully and covering more frequencies. The hope is that one day, a signal will be detected that changes everything we know about our place in the universe. Until then, we keep listening, waiting for the day when the cosmic silence breaks. 96. Terraforming and colonizing worlds. One day, humans may no longer call Earth their only home. Scientists and engineers dream of walking on other planets like Mars, building settlements, and even terraforming alien worlds, changing their environments to make them livable for us. Mars, for example, is cold and dry with a thin atmosphere, To live there comfortably, we'd need to thicken its atmosphere, warm the planet, and maybe even create oceans or lakes. This process, called terraforming, will take centuries or longer, but it's not impossible. Researchers are already studying how to release gases trapped in Mars's soil to create a greenhouse effect that could warm the planet. Beyond Mars, moons like Europa or Titan could hold hidden oceans beneath ice. If we can warm these places and build habitats, life might thrive there too. Colonizing other worlds would reduce the risks of humanity relying on just one planet. It would expand our chance to survive in the long term. Though the challenges are huge, radiation, gravity differences, distance, humans are creative and determined. Life finds a way, and so will we. The future might see humans living among the stars, changing strange new worlds into new homes. 97. Generational ships and deep time. Traveling to other star systems will take an incredibly long time, far longer than any single human lifetime. To solve this, scientists imagine building generational ships, massive spacecraft that carry entire communities through space for hundreds or even thousands of years. On these ships, people would live full lives, being born, growing up, working, and dying, without ever seeing the destination planet. Instead, their children, or grandchildren, would be the ones to arrive and start a new life. These floating cities must be self-sustaining, recycling air, water, and food, and supporting social and emotional needs. Imagine entire families living inside one ship, with schools, farms, and even places to relax and play. The ship becomes a small, moving world. Generational ships are humanity's way of handling deep time, journeys longer than any human lifespan. They show how exploration may be less about fast travel and more about trusting future generations. It's a powerful reminder that space travel isn't just a technological challenge, but a test of patience, hope, and long-term thinking. 98. Imagination and exploration. Though humanity has only just begun to explore space physically, our imagination has traveled far beyond what we can reach today. We dream of black holes, cosmic monsters that swallow light and matter, and imagine strange, new life on distant planets. We picture traveling through time, exploring alternate dimensions, and uncovering secrets beyond our senses. Imagination is the first and most powerful tool of exploration. Before rockets, before telescopes, we dreamed about the stars. Every scientific breakthrough started as a simple idea in someone's mind. Without imagination, none of our discoveries or journeys would exist. This power to dream pushes us forward, making the impossible seem possible. It's why humans continue to ask big questions and reach for the unknown. Even when we can't physically travel to the farthest galaxies, our minds explore them. So don't underestimate your imagination. It's the seed of all human progress and the first spaceship that took us beyond Earth into the endless universe of ideas. 99. The universe in your mind. You are made of atoms forged in the hearts of stars that lived and died billions of years ago. The very stuff inside you, carbon, oxygen, iron, was created by ancient stellar explosions. Your brain is a remarkable collection of cells, arranged in a way that allows the universe to think about itself. When you imagine galaxies, time, or black holes, you are the cosmos reflecting on its own existence. You are not separate from the universe. You are part of it. The atoms in your body and the stars above share the same origin, connected across billions of years and vast distances. Your mind is a tiny window into the vast cosmos. It allows you to wonder, question, and understand. Through your thoughts, the universe becomes aware of its own story, its beginning, its laws, its mysteries. So when you look at the night sky or contemplate life, remember that you carry a piece of that universe within you. You are a living reflection of the cosmos. A moment when the universe looks back at itself. 100. You are the cosmos. Dreaming. At the end of this cosmic journey, we find something beautiful and profound. From the first atoms to the immense black holes, from the Big Bang to your own heartbeat, everything is connected in an endless dance. The universe is enormous and ancient, yet inside you lies its consciousness, the awareness that thinks, dreams, and wonders. You are the cosmos dreaming itself awake. Your thoughts and feelings are part of this vast unfolding story. Tonight, as you rest or look up at the stars, let yourself drift and imagine. You are more than a tiny speck in space. You are the universe becoming aware of its own existence. This connection is a reminder that you belong to something greater, a cosmic story that stretches across time and space. You are not just living in the universe. You are the universe, alive and dreaming.